Okie dokie, this is Notes 9.2 Part 2. Let's pick up where we left off here. We have find the mass of NaCl needed to prepare 2.5 liters of a 0.15 molar solution. Boy, that's a lot of stuff to think about. And whenever I get these molarity questions, right off the bat, what I do is I highlight that. I say, okay, this information was given to me. And what can I do with this information? I can unpack it. And what do I mean by that? Here's what I mean. I could say that 0.15 molar solution NaCl really equals 0.15 moles per 1 liter. Notice this right here equals this right here. That's what I mean by unpack. Okay, moles per liter is big M, molarity. Okay, so once I have this, I know that I've got a conversion factor. When I have the number of moles, I can also go to grams. I could go to number of grams. How do I do that? I use molar mass. Molar mass. So with moles, I can go back to grams if I need to. Okay, and that's what this question is asking you to do. Okay, and it's a little bit tricky. So it says I've got a 2.5 liter solution of NaCl. Okay, so I'm going to go from liters to moles to grams. That's what I'm going to do. How do I do that? I put this over 1 because that's my given. I use this guy right here. Or another way to look at it is just, I could just follow this roadmap. I put moles here. Okay, I put moles there. That's where I'm going to. What do I need to cancel to get to moles? I need to cancel out liters. Then I'm going from moles to grams. I could put grams right there. What do I need to cancel out? I need to cancel out moles. So that's it. If you could at least do that, then that gives you a hint. It's like figuring out using the units before you even plug in any numbers. Well, moles, if you could just remember, moles per liter, that's molarity. That's this thing right there. And I look at that relationship, well, it's written, I just write it out the way I have it, 0.15 moles per 1 liter. Cool, that step's done. Now, grams per mole, what is grams per mole? Let's look at this unit. That unit it's called molar mass. It's got a special name. Just like this has a special name, molarity. This also has a special name, grams per mole. It's called molar mass. Molar mass. Okay? And what molar mass are we using? We're using the molar mass of NaCl. Well, what is the molar mass of NaCl? Well, look on your periodic table. I don't have one with me, but I remember, because I've done this so many times, that 22.99 is sodium. And Cl, chlorine, is 35.45. I've memorized it because I've been doing this for so long. Okay, so you add those up and it comes out to 58 point something or other. Oh, here, let me just add it up. I can't do it in my head. It's too early in the morning. 22.99 plus 35.45, 58.44. 58.44. And that's grams per 1 mole. Check it out. Look, that's my molar mass, guys. That's it right there. That's what I needed. You see that? Now I can plug that into there. Okay, so I plug in 58.44 grams per 1 mole. This is why I told you always write out your units, because we're getting now into these more complicated problems here. And I cancel all those out. It leaves me in grams. That's where I'm going to. Okay, so now how do I solve this? I look at my denominator. There's a 1 in the denominator, so I don't have to do any division. All I have to do is multiply 2.5 times 0.15 times 58.44. And when I do that math, I get, or I should say Mr. Koo got, 21.9 grams. 21.9 grams. Okay, that's how you do that. 3 steps. Volume to moles. Moles is your key always. Once you're in moles, you can go convert to anything you want to convert to. Liters to moles to grams. That's how you solve that. Okay. If you get stuck on them, you come and see me. I'll let you go ahead and write all this stuff down. Okay, the back side of the notes is dilutions. So how do we perform a dilution? Well, first we made a molar concentration, right? We did a concentration. We created a solution. Now let's say that I've got a very strong solution. I don't need it that strong because it would be wasteful. I would want maybe, or dangerous, or both. I might want to add water to it to dilute it. So how do I do that accurately? I obtain a volumetric flask for the volume of solution that you want to prepare. Transfer a small volume of this concentrated solution to the volumetric flask. So let's say this was really super concentrated, maybe 20 molar. Okay, what I would do is I'd get a bigger volumetric flask of, let's say, a half a liter, 500 mils. Okay, I would take a small amount from here and I would measure it. I'd put it in the new flask and I would add water. Stir the solution, and then there's a formula. It's V concentration times molarity of the concentration, that would be this, equals the volume of the dilution times the molarity of the dilution. Okay, so moles of solute added from stock is unchanged. Well, okay, don't worry about that. You don't need to worry about that. Just cross that out. Okay, go ahead and copy this. Oops. Go ahead and copy all of this. Let me zoom in. Okay, the next example is find the volume of a 3.4 molar stock solution when required to prepare 150 mils of a 0.4 molar solution. Okay, that's easy enough. This is a dilution. This is a dilution. Okay, so we write out our variables. You say volume of concentration, molarity of concentration, volume of dilution, and molarity of dilution. Molarity of dilution. Okay. And the volume of the concentration. Find the volume of a 3.2 molar stock solution. That means concentration. Required to prepare. Let's just say concentrated solution. Okay, that was the concentrated solution. Required to prepare 150 mils of a 0.4 molar dilution. Dilution. Okay, so 3.2 molar concentration. Okay. Volume of our dilution is 150 mils of a 0.4 molar solution. Okay, because molarity is written as in moles per liter, we have to convert this mils to liters. Okay, so it's 0.150 liters. So volume always needs to be in liters, folks. Okay, volume always needs to be in liters. So here's how you do this. VC of the concentration, MC, equals VD, MD. Okay, I'm solving for VC. That means I divide both sides by MC. MC. I cancel that out like so. So there's my formula. Okay, VD, MD divided by MC. So let's go ahead and plug those in. That's going to be 0.150 liters times M of our dilution, 0.40 molar, okay, divided by MC, in this case is 3.2 molar. Molars cancel, leaving us in liters. Oh, jeez, I'm sorry, I didn't even realize that was off the screen there. Okay. There you go, let you get caught up. Okay, again, that's our VC of our concentration, volume of concentration, volume of dilution times molarity of dilution divided by molarity of concentration. The molar units cancel. Okay, and when we do that math, we should get 0.0188 liters of solution. That's how much the volume of the concentration that we need to transfer over into our new volumetric flask. Okay, there you go. That's how you do those.